Okay, thank you again, then, for joining me in this edition of the Data Science Incubator. I changed the title of this session to make it even kind of higher level because I learned of some very good documentation about the topic I wanted to kind of address, and better than the one that I thought originally. So if you saw some change in the title, it's expected. And now this session is called Avoid Hidden Arguments. I think it's a kind of more general principle than the one that I wrote before. It was about basically writing pure functions. I think this is more evocative, and I hope that examples will relate to our work. So the material I'm showing, or the most of the text that I'm showing here comes from a book, an open source book that is called the Tidyverse Principles. It is the Tidyverse Design Guide, and it has a bunch of really cool and nicely written pieces of advice that I use myself, and I'm still discovering new things. I've learned a lot writing this presentation today. So I've seen a very common pattern in 2degrees code that usually is difficult kind of to work with. So I want to kind of show the principle behind the changes in that code that I would suggest. So the principle basically is that hidden arguments make code really hard to reason about, because to predict the output of a function, we also need to understand what's the state of some variable or some other state other than the inputs of the function. So here in this code snippet, I'm showing first, I'm storing the value 1 in the variable y, and then I'm writing a little function that is called add, and what it does, it takes the input x and then adds y. So for example, if we pass the argument, the value 1 to add, then what we get is 2, because now x has the value 1, but then it adds y, and y is also 1, so the output is 2. But notice what happens if, somewhere along the script, the variable y changes from 1 to 10. This is kind of very clearly shown here because there is not a lot of code. But imagine a script that is 1,000 lines or something, and somewhere along the script, the variable y changes to 10. So now we call the function add1, so with the value 1. But because y is 10, then what we are doing is effectively, adding 1 to 10, so the value is 11. And this is quite surprising because the same call to the function add with the input 1 now produces 2 different results. Before it was 2, and now it's 11. So this is very surprising, and is generally ill-advised. So what we want is that all the inputs of functions should be explicitly shown in the, should be given, all the inputs should be, explicitly given in the signature of the function. So functions are way easier to understand if the results depend only on the values of the inputs. But I'm going to show later, after some examples, some cases of functions that do need to access some global state, and when it's a good idea and when it's not. So let me show you, if we do have code that is written that way. So what can we do about that? And this comes explicitly from, or literally from the guide that I mentioned before, the Tidyverse Design Guide. So basically, if you have a function that has that issue, it has hidden inputs, then there's 2 steps that we can take. So one is to make sure that the inputs are now become an explicit option. And 2, if depending on the kind of input, you may want to kind of print some message telling the user what decision has been made. And let me show that with an example, because so far it must be very abstract and difficult to understand. So let's take this function as an example, prepare data. What it does is reads some file from some path, stores the value in data, and then only selects the first 2 rows and the first 2 columns. So let's call that function prepare data. So now, at the in the global environment of my session, I'm creating a path to that file because I don't want to write into my file system. So for this example, I'm just using the temporary file that will kind of disappear when this session ends. So I'm storing, basically what I have here is just a path to a file. And into that path, I'm just writing a toy dataset, the empty cars, the famous empty cars dataset. So I'm storing it into that path. So what I have here is just, now let's you can just think that, at the path that I wrote here, I have a file. That's all I want to do. So this is the little setup that I need to demonstrate the example. So now, because path has an actual path to a real data set, the data set empty cars, when I call the function prepare data, so that path, what we'll do is, so the function prepare data, what we'll do is kind of read that empty cars file from that path, storing data, and do the action that I wanted. So it kind of looks, okay, that it's working. So prepare data does what I wanted to do. It prints the first 2 rows and the first 2 columns of the empty cars data set. But remember, let's go one step behind. So we have a hidden argument. The hidden argument is data. And the first thing we should do to remediate this problem would be to make sure that the input is an explicit option. So let me show you, what that would look like. So what's the next step? So we have this function. What do we do next? Okay, so data, remember, it was here, the first line. So now data moves to the definition of the function. And that's about it. All that we need to do for step number 1. We still have some work to do with this function, but at least data is explicitly an argument in the signature of this function. So we see how it is defined, and we know that it needs data. So the user has at least if the user prints the signature of the function, you can see, okay, data is a required argument. But still, because data has a default read CSV path, and path does exist in the global environment of the user, then just calling the function with no arguments would still produce output. So, well, okay, you might think, okay, that's great. So the user doesn't need to type anything in here, and they still get what they want. But we are still relying on that path living in the global environment, and the global environment is something very ephemeral, something that as soon as I press Ctrl+Shift+F10, I restart my session and everything is gone. So it's not a very good idea. So let's see now step 2. Remember, so we did step 1, which was to now prepare data against the explicit argument data. So that was step 1. Now step 2 would be to at least inform the user very explicitly the decision that we are kind of making. So that would be one way to improve this function a little bit. So what we could do is say, well, okay, if the argument data is missing because a user hasn't explicitly given the argument data, then we can print a message, something like using data with names, and just give the names of the data set. So what it could look like is something like this. So if the user calls the function with no argument, then they will see this message using data with names, and in this case, it's the names of the empty cars dataset. So it's a little bit more informative, even if the user doesn't have to intentionally pass what data needs to be prepared. They still get some information about, okay, it makes sense. These columns are the ones I was expecting, for example. But then if they do pass the argument data, like in this second call to the function prepare data, notice that instead of not passing anything, I am actually passing the argument read.csv path. So I am passing the argument data. And in this case, because the user is giving that argument, then we don't need a message, right? And that's what the function does, because now the argument data is not missing. So okay, it kind of behaves as we expected. But then even better could be to kind of reflect on what kind of argument is data. So we do need data. It is the main argument of the function. It's not a detailed argument. It's not something that modifies some property of the function. It is the most important argument. And the Tidyverse design guide recommends that for data arguments, because they are core data, we should, require those arguments. We should ask the user to do that extra effort and give us that data, because it's such an important argument that the user have to be very intentional. That way, they're very sure, very much in control of what the output is going to be. And it also recommends that those arguments are usually called data, as I showed in the example, or maybe usually when they are data frames, or they might be called X or Y, like in, for example, the function from dplyr, say, left join, that it uses X and Y. So what would happen now if we do that change? So if now data does not have a default, meaning that it is a required argument, notice that the function becomes way simpler. So it's not only now according to kind of best practices, but it's also super simple. It doesn't have a default here, and we don't need to check for missing data because we are forcing data to be given by the user. So now if the user calls prepare data with no argument, I'm using the function try. I'm wrapping this call to around try, so that I can show the error, but I can still run this code. So notice that we get automatically an error that says error in prepared data, the argument data is missing with no default. And we get that for free. We didn't have to do any, if data is missing, do this or do that. That comes from free by not setting a default to data, which is a very nice behavior. And we obtain that in a very clean way. So now the way we would ask our users to use our function would be, so they actually, they create a data frame outside the function, maybe like this, by storing the object in data and then passing that data to the function, or maybe just writing this just inside here. So that's the end of this, what's called refactoring. The recommended way of writing this function. Before, we were reading the data inside the function, and now we are forcing the user or asking the user to read it outside and then passing the resulting data frame into the prepared data function. But okay, sometimes some functions do need to depend on some kind of external state. For example, but when that happens, we may or may not surprise the user with the behavior of the function. So a function has hidden arguments, as we showed before in an example, but if we articulate that, when it returns different results with the same input in a surprising way. Let me show you what it could be surprising here, for example. Let me demonstrate a call to the function data.frame. So we create a data frame that contains a column X, and it has just the value A. So if we now extract the column X from this data frame that we just created, what we get depends on a global option. The global option strings as factors. So with the global option that comes by default, that global option is true. So with that global option, data.frame would return a factor. But now, if we change all options to be strings as factors equals false, if we call the exact same function, if we call data.frame, and we do exactly the same thing, so this is exactly this, now we don't get a factor, what we get is a string. So that is a poor design of data.frame function. That's why we always need to kind of type, or very often we need to type strings as factors equals false when we create a data frame or when we read a file with the function read.csv. So that's not ideal, and it remains like that for mostly historical reasons. I mean, changing that would be a pain. It would break so much code. But generally, global options are required, but generally, or sometimes are required, but generally it's a good idea to use them only for display. Like, for example, how many rows of a data frame you want to print on your console or something like that. But they should generally not affect computation. So in this case, it does affect something that is computed, and it's not a very good idea. And finally, and that's the last slide of this presentation, there are other functions that do also depend on global state, but the result is not surprising. So there is no problem with that. So for example, the function read_CSV called with a particular path, of course, depends on the path, which is the input, but of course, it depends also on the contents of the file to where this path is pointing. So, but that's fine, right? Because you expect, so you want to read a particular file, so you expect to get what the file contains. So that is an external effect, something that is outside the inputs, but still it's not surprising. So there's no problem with read CSV really. So if I show that example here, maybe it's a little trivial, but let's write a file to a path, and then let's see what are the names of that path. So I call the function read_path, read_CSV with the argument path, and I get the names in this first case of empty cars because I have just written empty cars to this path. But now if I write iris to the same path, of course I will get something different. But that's not surprising. That's precisely the purpose of this function. So that is what I wanted to demonstrate. I hope to have kind of prompted some reflections about the code that we already have, and given you some guidelines about kind of demonstrating what problems you might encounter with that code, and give you some guidelines about what to do next if you wanted to kind of change that code from the state it is now to something that is easier to work with in the future. With that, I'm finishing my presentation, so I look forward to your questions.
Thank you.
Thank you, Mamudu.
Berlin doesn't seem to have questions.
I do have one question.
Mm-hmm.
So can you go to your slide number 8?
Let's see. Two. Yeah.
And I am confused what happens if the data option is missing,
Mm-hmm.
and this missing data is true. So then this message begins, and then you're taking the names of data which hasn't been passed. So does that then depend on this object data being available in your global environment, but not as one of the arguments of the function? Or like, I would kind of expect that the message function to actually error out unless the data object or an object named data existed in either your global environment somewhere else that this would have access to, right?
Okay. Yeah, this could easily have a bug because it's an example that I typed myself fairly quickly. So the names of data. So here we are passing. Okay, so here we are passing data. Okay, so data here is available here in names data because so this data comes from here and this comes from here, and path is in the global environment. I defined this path like 1 or 2 slides ago here. So path is pointing to this CSV file. So yes, certainly if path wouldn't exist, then this could be an error. That's right.
Yeah.
Yep.
But I guess like it's also weird because the missing data essentially would never happen in this function, right? Because it has a default value.
Well, like in this case, so in this case here, so I'm not explicitly passing. So see that this is the same call, except that here I pass the argument data explicitly. The user is passing the argument data explicitly, and the only difference is that this one doesn't print the message. So this if missing data doesn't, we are not entering this if statement here.
So missing data will give you a true if you didn't explicitly pass data, but the data object is still set by default. Is that correct?
There's no data. There's a
yeah. Actually, maybe I don't understand very well missing, because I was actually surprised myself of not seeing the printed message here, but I did copy this example from the book. I also had expected to something a little different, showing that I probably don't understand missing data very well.
I might experiment with it a little bit.
Yeah, but that's why I'm learning a lot, because sometimes I think I understand something fully and then I don't. It's kind of cool what I see actually here. I was surprised in an interesting way. Yeah, sorry. I think that this conversation was a little geeky. Maybe it's not super relevant to the most important point, I guess, is that those functions that we see very often in our code that depend on some data sets that are not giving us inputs are really difficult to work with and very difficult to test and very difficult to predict what's going to happen. So basically, I'm just trying to give you some tools to very slowly and as you touch that code, to start moving those arguments to the signature of those functions.
So I have one other just quick comment. If you go to slide 9, I believe.
Yep. Mm-hmm.
Maybe it's no, this is it, yeah. So the error that you get here, my understanding is that you don't get that until like something in the function actually attempts to access that object, just as a thing to be aware of. For instance, if your prepare data function was doing like lots of calculations, potentially some that are like super expensive,
mm-hmm.
And then not ever accessing the data object until later on in the function, all of those expensive operations would happen before you got this error. As I understand, this error gets thrown as the first time that object is intended you try to access it. So it's something to be aware of. Like you do get that error message for free, as you said, to the point, but there are conditions in which you may want to more explicitly check for that and not take the free version.
I agree. Yeah, right. Yeah, because of the lazy evaluation, right? Is that what it's called in the R jargon?
Exactly.
Yeah. Yeah, it can be tricky. In other languages, it's not allowed, as I understand, although I'm not fluent in other languages. But I understand that that's just not an option. But in R, it's so flexible that you can do something like that. You can make a required argument, but if you never try to access that argument, the function will just work. Okay, the Tidyverse design guide is work in progress. The last time I read it was probably 6 months ago, and I thought, oh yeah, I kind of learned a few things. And now I revisit the guide, and I am learning more things. So I'm very motivated to reread it. I don't know if I should advise you to have a look or not, because there are some sections that are still incomplete. But it's something to keep in mind, because not so much because I think it's the best way to go about things, but mostly because it is one way in which that is documented. So I think that when there is documentation somewhere that we can refer to, it is easier to come to a consensus than when we just depend on how people like doing things. So with this, I'm trying to say, maybe some of the principles that I'm demonstrating here in general, you may not like them that much, and sometimes I don't like them that much either. But I sometimes prefer to just join a club that is already going on than to try to force people do things my way. So yeah, is there any other question or comment?
Not in Berlin.
Okay, cool. Thank you very much then. I close the session and I look forward to the next one.
Thanks, Mauro. Ciao.
Bye-bye.